What if, right now, there are infinite versions of you, some only slightly different, others living lives you could never imagine? One you never skipped that class, one you took that risky job offer. One who never met the people who shaped your destiny. This is the multiverse dilemma, the possibility that every decision you make, every quantum coin flip, spawns a new reality. In one universe, you're watching this video in your living room. In another, you're not even human. And here's the real mind bender. If the multiverse is real, there is no you, only endless variations, each believing they are the original. Physicists, philosophers, and mystics have wrestled with this for decades. From quantum mechanics' many worlds interpretation to ancient Hindu cosmology's endless cosmic cycles, the idea keeps surfacing as if reality itself is hinting at something we're not ready to face. But the question isn't just if the multiverse exists. It's what it means for your identity, your choices, and your soul. If infinite versions of you exist, do you still matter? Or do you matter more than ever? Let's step across the veil of the familiar into a reality where the boundaries of self dissolve and every choice is a doorway to another you. Chapter 1. The Birth of the Multiverse Idea. It begins, as so many great questions do, with the oldest human act, looking up at the night sky. Imagine standing in a clearing thousands of years ago. No street lights, no hum of cities, just a dome of stars so clear it feels close enough to touch. Our ancestors stared into that depth and felt to things at once the smallness of their own lives. And the vastness of something they could not name. Was there only one sky, only one world? Or could there be others, hidden beyond sight, parallel to ours, or scattered endlessly in the darkness? From myth to many worlds, long before multiverse was a scientific term, it was a mythological instinct. In Hindu cosmology, creation isn't a single event but a breath, universes born and dissolved with each inhalation and exhalation of Brahma. The Maya spoke of layered heavens and underworlds, each a complete reality of its own. Norse mythology tells of Yggdrasil, the world tree whose branches and roots connect 9 realms, each with its own beings, destinies, and laws. These weren't just stories, they were answers to a gut-deep suspicion that this reality might not be the only one. The philosophical leap, the idea took on sharper edges in ancient Greece. The philosopher Anaximander speculated about innumerable worlds born from a boundless, eternal substance. Democritus and Epicurus argued for infinite space scattered with countless atoms forming endless worlds, some like ours, some utterly alien. It wasn't mysticism to them, it was a logical extension of the idea that nature repeats itself. If the universe is infinite, why would it stop at just one world? The religious paradox, even within monotheistic traditions, the possibility of multiple worlds crept in. Medieval Islamic scholars debated whether God's power could be limited to creating only one universe. Some Christian thinkers wrestled with the question, would an all-powerful God choose just one creation or many? The tension was clear. Multiple worlds could either expand the glory of creation or destabilize the uniqueness of our own story. The scientific awakening. By the 17th century, telescopes were turning speculation into data. Galileo's revelations that Jupiter had moons, that the Milky Way was a river of countless stars, suggested the cosmos was more populated than imagined. Giordano Bruno took the next step, declaring that every star could be a sun with its own inhabited worlds. For this, he was burned at the stake. Not purely for astronomy, but for the heretical implication, if there are infinite worlds, perhaps we are not central, perhaps not even special. From worlds to universes, for centuries, other worlds meant other planets. But as the 20th century dawned, physics shattered that boundary. Relativity revealed that space and time were not fixed, they could curve, stretch, and perhaps split. Quantum mechanics then whispered something more unsettling. Reality itself might branch over and over with every choice, every particle interaction, every breath. Now the question wasn't just are there other worlds out there? But are there other versions of me out there? The stage is set. From ancient fireside myths to chalkboards covered in equations, the idea of many worlds has transformed but never faded. At each step, it is pressed against the edges of our comfort, challenging our sense of uniqueness, our certainty of reality, and our definition of everything. And so we arrive at the modern multiverse dilemma, where cosmology, quantum theory, and philosophy converge on a strange possibility. You are not singular. Your life may not be unique. There could be infinite yous living infinite lives right now. In the next chapter, we step into the heart of modern physics, where equations that began as abstract math began to whisper about other universes, and where a simple question became an existential riddle. Chapter 2: Quantum Branches and Parallel Lives. It begins with a problem so small you could hold it in your hand, smaller, even, than the atoms in your skin. In the early 20th century, physicists discovered that the rules governing the tiniest pieces of reality were unlike anything in the visible world. Particles did not behave like solid marbles moving along predictable paths. Instead, they existed in superpositions, ghostly clouds of probability, as if they occupied many states at once. A particle could spin both clockwise and counterclockwise. An electron could be in two places at the same time, and it wasn't until you measured it that it chose a definite state. This bizarre framework was called quantum mechanics. It worked flawlessly to predict experiments, but it carried an unsolved riddle. What, exactly, happens when reality chooses? The Copenhagen curtain, the traditional answer, the Copenhagen interpretation, suggested that reality is indefinite until observed. The act of measurement collapses the fuzzy wave of possibilities into one outcome. For decades, this was treated as a pragmatic, if unsatisfying, solution. But one young physicist named Hugh Everett III looked at this and saw something extraordinary. What if nothing ever collapses? What if every possible outcome actually happens, but in a different branch of reality? The many worlds interpretation. In Everett's 1957 thesis, he proposed that the universe doesn't choose one path, it splits. At every quantum event, the world branches. You flip a coin. In one branch, it lands heads. In another, tails. Both outcomes exist, equally real, but forever separated, like pages of a book that can never touch again. It's not just coins. Every choice you make, every photon of light scattering off your face, every neuron firing in your brain, all of them split the cosmos into parallel realities. In one branch, you are reading this sentence. In another, you are not. In one, you became a musician. In another, a doctor. In another, you never made it past childhood. Infinite you. The implications are dizzying. If the universe branches constantly, then there are versions of you living through every possible history. There is a you who took that risk. A you who didn't. A you who lost. A you who won. A you who never met the people who define your current life. It also means your life is not a single line, but a sprawling tree with endless limbs, most of which you will never see. And yet, each branch is as real to its version of you as this one is to you now. A universe without collapse. Everett's model solves one of quantum mechanics' biggest headaches, the collapse problem, by removing collapse entirely. The wave of probabilities never collapses. Instead, the universe as a whole evolves smoothly, splitting into branches where every possibility plays out. To an observer inside one branch, it feels as if only one outcome occurred. But step back. If that were even possible, and you would see an infinite quilt of universes, each as vivid and solid as our own. The resistance, when Everett first presented his idea, it was met with skepticism, even ridicule. Not because it was mathematically unsound, but because it sounded like science fiction. The thought of countless copies of reality endlessly multiplying was philosophically and emotionally unsettling. Niels Bohr, the father of the Copenhagen view, famously avoided debating it in depth. Others dismissed it as untestable and therefore unscientific. Everett himself left academia, frustrated by the lack of engagement, but his idea didn't die. From fringe to framework, over the decades, many worlds slowly gained traction. It offered a clean, elegant explanation for quantum phenomena without adding arbitrary collapse rules. It also began to inspire experiments that, while not proving it outright, showed how strangely real quantum superpositions can be, from particles interfering with themselves to quantum computers exploiting parallel states. Today, many worlds is one of the leading interpretations of quantum mechanics. Not proven, but taken seriously enough to be discussed in the same breath as Copenhagen, pilot wave theory, and other frameworks. The existential shockwave, if many worlds is true, it appends our deepest assumptions about identity, choice, and fate. Your successes and failures are not unique. Somewhere, another you has already taken the opposite path. Somewhere, another you never experienced your worst loss or your greatest joy. And here's the strangest part, these other yous are not ghosts or fantasies. They are just as real as you are, living in universes where their reality feels as solid and singular as yours. Chapter 3. The Cosmic Multiverse, Beyond Quantum Branches. If the many worlds interpretation paints a picture of reality splitting at the smallest scales, cosmology offers an equally staggering expansion, not just branches within a single universe, but entire universes, each with its own birth, its own physics, its own destiny. The idea begins with a simple question: why is there anything at all? The beginning that wasn't the beginning. For much of the 20th century, the Big Bang was seen as the ultimate origin, a singular moment when all space, time, and matter burst forth from a point smaller than an atom. But in the 1980s, physicist Alan Guth proposed a twist called cosmic inflation, the idea that in the tiniest fraction of a second after the Big Bang, the universe expanded faster than the speed of light. This inflation smoothed and flattened space, setting the stage for the cosmos we see today. The shock came when researchers realized inflation might not have been a one-time event. Under certain conditions, it could be eternal, still happening, even now, in faraway regions of reality. Bubble universes, if inflation never truly ends everywhere, then space becomes a frothing sea of expansion. In some pockets, inflation stops and a bubble universe forms, cooling and giving birth to galaxies, stars, and life. Our universe would be just one such bubble, and beyond our bubble, countless others, forever beyond our reach, each sealed off by regions still inflating at incomprehensible speeds. These bubbles could have different physical constants, different numbers of dimensions, even entirely different laws of physics. In one, gravity might be weaker. In another, atoms might never form. In another still, stars might ignite in colors our eyes could never perceive. The landscape of possibility, string theory adds another layer. It predicts an enormous landscape of possible vacuum states, different stable configurations of spacetime and fields. Each bubble universe could land in a different configuration, meaning its physics could be utterly alien. This is not just science fiction speculation, it's a consequence of how our best mathematical models can work. If they're right, the number of possible universes could be so large it makes infinity feel small, connecting the quantum and the cosmic. At first glance, quantum many worlds and cosmic bubble universes seem unrelated. One deals with micro-reality, the other with macro-reality. But some physicists have wondered, could these be two faces of the same truth? Perhaps every quantum split doesn't just create a new branch within our universe, but actually seeds a new universe entirely, a branching multiverse that is both quantum and cosmic. In this view, you wouldn't just have another version of yourself in some abstract possibility space. That version would inhabit a fully formed, physically separate cosmos with its own galaxies and history. The inaccessibility problem, here's the catch: these other universes, whether quantum branches or inflationary bubbles, are by all practical means unreachable. The distances are too great, the barriers between universes to absolute. The speed of light and the nature of spacetime itself lock us inside our own cosmic bubble, which raises the philosophical question: if we can never interact with these other universes, do they really exist? Or are they a mathematical mirage, a useful story but not a tangible reality? The observer's cage. Imagine standing in a vast library where each book is a universe. You are locked inside a single book, you can never touch the others, never even see their covers. Yet the library itself exists, not just as a metaphor but as a logical consequence of the physics that made your own book possible. We are, perhaps, like characters in one of those books. We live the story in our chapter, oblivious to the infinite pages turning all around us. Why it matters: if the multiverse is real, it changes how we think about meaning, chance, and existence. Why does our universe seem so perfectly tuned for life? In a multiverse, this is no miracle. Life simply appears in those universes where the conditions allow it. In the infinite spread of possibilities, we find ourselves in one of the rare chapters where consciousness can emerge. It also reframes the concept of destiny. In one bubble, Earth may have perished in its infancy. In another, humanity may have reached the stars millennia ago. Our choices still matter, but they are written on a page in a book that may be mirrored, rewritten, and rewritten again across an infinite shelf. Chapter 4: The Doppelganger Problem, Infinite Copies of You. If the multiverse is infinite, truly infinite, then somewhere out there is another you. Not just similar in personality or sharing your birthday, but an exact copy. Same memories, same dreams, same mistakes, and that's just the beginning. The math of repetition, it starts with a strange but simple fact from probability. If you have infinite chances, patterns must repeat. In an infinite multiverse, every arrangement of matter that can exist will exist not just once, but infinitely many times. This isn't mysticism, it's statistics. Think of the universe as a cosmic slot machine spinning out combinations of particles instead of cherries and lemons. Given enough spins, every combination will come up again and again and again. That includes one combination that is you sitting exactly as you are now, reading these words. The distance to your twin. The cosmologist Max Tegmark once calculated that, even if space is infinite, the nearest exact copy of you might be unimaginably far but still finite, away. The number: about 101,028 meters. That's A1 followed by 10 octillion zeros. It's an absurd number, far beyond the scale of galaxies or even the observable universe, but still. A real distance somewhere in that incomprehensible span. Another Earth orbits another sun. And on that Earth, another you woke up this morning, poured the same coffee, and is now wondering about you. The almost yous, even stranger than exact duplicates, are the near misses, versions of you that are almost the same, except for a single deviation. In one universe, you wore a red shirt today instead of black. In another, you became a musician instead of an engineer. In yet another, you never met the person who shaped your life the most. Some near versions diverged yesterday, others split decades ago, leading to wildly different fates. The psychological uncanny, the idea of infinite copies, is both comforting and unsettling. Comforting because maybe in some universes you avoided your worst mistakes. Maybe in some you achieved your greatest ambitions. Unsettling because in others your life went much, much worse. And those yous, they are you in every meaningful sense. Same soul, different roll of the cosmic dice. It forces the question: if there are countless versions of you, each living their own joys and tragedies, what makes this one, the you here and now, special? Identity under pressure. Philosophers call this the problem of personal identity. If two versions of you share all the same memories up to a certain point, are they both you? Or does identity depend on continuity, the uninterrupted flow of your own subjective experience? In the multiverse, identity becomes fluid. Your consciousness is the thread you follow, but it is only one of many threads woven from the same origin. Ethics in the multiverse: if there are infinite yous, does your moral responsibility shrink because somewhere else you made the right choice? Or does it grow because your actions here ripple into the meaning of all the versions of you that exist? Some argue that the multiverse doesn't cheapen our lives, it magnifies them. Even if there are infinite copies, this moment is still yours alone. The choices you make are the only ones that will shape the world you inhabit. Meeting yourself, science fiction has long been obsessed with the idea of meeting one's alternate self. Usually, it's portrayed as either a disaster or a revelation. But if multiverse theory is correct, such a meeting is likely impossible. The barriers between universes are too absolute. And yet, some physicists speculate that rare quantum events or as yet known physics might allow for crossovers. If that were true, meeting another you might be the most profound and destabilizing event imaginable, a living mirror of what you could have been. Why it haunts us, at the heart of the doppelganger problem, is a deep human truth. We are all haunted by what if. The multiverse takes those what ifs and gives them flesh somewhere out there. It says, yes, those lives exist, they're being lived right now by versions of you who are as real to themselves as you are to you. It's both exhilarating and existentially vertiginous. Chapter 5: The Infinite Decision Tree. Every choice, every universe. Every decision you make feels like a narrowing of possibilities. You choose one path and the others vanish, or so it seems, but in the multiverse, nothing vanishes, instead, reality branches. Every yes and no, every hesitation, every unnoticed gesture, each becomes the root of a new universe. The tree without end. Imagine your life as a vast decision tree. At the root is the moment you were born. From there, each choice, big or small, causes the trunk to split. Most branches are small. You turn left instead of right on the way to work. Some are huge. You decide to move to another city or not. In a finite world, these branches are theoretical, just roads not taken. But in an infinite multiverse, each one is real, unfolding in parallel. The physics behind the branches: this idea comes from the many worlds interpretation of quantum mechanics proposed by physicist Hugh Everett in 1957. In quantum theory, particles don't have definite states until they are measured. Before that, they exist in a superposition, multiple possibilities at once. Everett's radical suggestion was, what if the universe doesn't collapse to one outcome when a measurement is made? What if all outcomes happen, each in its own branch of reality? And because you are made of quantum particles, you branch too. The quiet avalanche: it's tempting to think branching only happens in big, cinematic moments, proposing marriage, changing careers, boarding a plane. But branching is constant. Every blink, every breath, every micro-decision in your brain spawns new versions of reality. If this is true, there are universes where you paused a second longer before stepping into the street, and universes where that pause saved your life or cost it. The problem of infinite use making infinite choices. In the branching multiverse, there's not just one copy of you making better choices. There are copies making worse choices, copies making nearly identical choices, copies making choices so bizarre you can't imagine them. This infinite decision tree is not a simple map of good and bad paths, it's an explosion of every conceivable possibility. Free will in the branching universe. Here's the philosophical paradox. If every choice you could make is made in some branch, do you truly have free will? One perspective says no, your choices are just one version among infinite versions, none more special than the rest. Another says yes, because your consciousness follows one path at a time. You experience the version you choose, and that subjective reality gives meaning to your decisions. The weight of the path you walk. In a strange way, the multiverse can make your choices feel heavier. Even if infinite other yous exist, only this you can shape the branch you're on. Only here, in this thread of reality, can you love the people around you, heal from your wounds, and decide how your story unfolds. You can't control the other branches, but you can live fully in this one. The shadow of regret. We all carry regrets, moments we wish we could go back and change. The multiverse whispers, somewhere, you did. That can be comforting or deeply unsettling. Because it also means that somewhere you made the worst possible choice, and somewhere else an even worse one. The branches don't stop branching, and they don't always lead to happy endings. Glimpses across the branches. If all these parallel universes exist, could we ever sense them? Some researchers speculate that déjà vu, strange dreams, or sudden, unexplainable emotions might be tiny bleed-throughs, echoes from nearby branches. There's no scientific proof, but the idea persists in both folklore and quantum speculation. If true, maybe some part of you knows it has walked other paths, loved other people, and lived other lives. Why this chapter matters in the multiverse dilemma. The infinite decision tree shows that the multiverse isn't just about distant copies of you in far-off galaxies, it's about the constant unfolding of reality right here, right now. Every action you take is both the continuation of your branch and the seed of countless others. And in the next chapter, we'll explore the observer's paradox, how your very act of existing and perceiving might shape which branch you find yourself on. Chapter 6, The Observer's Paradox. Do we create the universe by looking at it? Imagine walking into a dark room. You fumble for the light switch, and in that instant, the shadows leap back, revealing everything. The walls, the furniture, the air itself now visible in the glow. But here's the unsettling question physicists have been wrestling with for a century. Was the room always like that? Or did it become like that because you looked? The quantum puzzle. In the world of everyday experience, reality feels solid. The table in front of you exists whether you're staring at it or not. But zoom in far enough, down to the level of subatomic particles, and things get strange, very strange. Quantum mechanics tells us that particles like electrons don't exist as neat little dots moving along predictable paths. Instead, they exist in a state of probabilities, a wave of potential positions and states, until something interacts with them. This is the wave function, a kind of cosmic maybe that collapses into a definite reality when measured or observed. This isn't speculation, it's been demonstrated again and again through experiments like the famous double-slit experiment. When not observed, particles behave like waves, passing through both slits simultaneously, creating an interference pattern. But when scientists watch, literally setting up detectors, the wave collapses and the particles behave like solid little bullets. The act of measurement changes the outcome. It's as if reality itself refuses to commit to a single version until someone, or something, looks. The consciousness question. This leads to a deeply unsettling possibility. If the act of observation determines how particles behave, could consciousness itself be fundamental to reality? Some interpretations of quantum mechanics, like the von Neumann-Wiener interpretation, flirt with the idea that the mind isn't just a passive witness but an active participant in shaping the physical world. In that sense, every time you observe something, you're not just recording it, you might be creating it in a specific form from a sea of possibilities. And if this is true on the smallest scales, what does it mean for the largest? Could the universe itself only exist in a definite way because it is being observed by us, by other conscious beings, or by some cosmic awareness? Ancient echoes of a modern mystery. Long before quantum mechanics, ancient traditions whispered similar ideas. In Hindu philosophy, the universe is Maya, an illusion or dream projected within the mind of Brahman, the ultimate reality. The Bhagavad Gita speaks of consciousness as the eternal witness of all phenomena, untouched yet central to their existence. In Buddhism, the mind is said to co-create reality through perception, intention, and karmic seeds. The outer world is inseparable from the inner observer. And in Western mysticism, Hermetic teachings repeat the axiom, the all is mind, the universe is mental. These ancient visions, though couched in spiritual language, eerily parallel the quantum riddle. Without the observer, there is no fixed reality, only potential. Bridging science and mysticism, now most physicists will stop short of saying consciousness creates the universe. They'll argue that observation in quantum mechanics can be performed by any interaction, not necessarily a human mind. A Geiger counter, a photon, or a stray atom could observe and collapse a wave function. But even here, the mystery deepens. What counts as an observer? Is it simply a physical interaction? Or is there something about awareness itself, the fact that some events are known, that locks them into reality? This is where some thinkers suggest a middle path. Maybe consciousness and the physical universe are two aspects of the same underlying reality. Like two sides of a coin, each meaningless without the other. The multiverse twist, here's where it loops back into our central theme. One interpretation of quantum mechanics, the many worlds interpretation, says that the wave function never actually collapses at all. Instead, every possible outcome does happen, but in separate, parallel universes. You look at a coin toss and see heads. In another universe, you saw tails. Every choice, every measurement, every quantum possibility branches the multiverse. In this view, the observer doesn't collapse possibilities. They simply become aware of one branch while infinite others unfold beyond their perception. This turns the observer paradox into something even wilder. You might not be creating reality from nothing, but your consciousness is tuning into one reality out of an infinite set. Like choosing a channel on a cosmic TV, you're locking into a version of events while countless others keep playing out on channels you'll never see. The personal implication, if all of this sounds abstract, consider this. Every moment you're alive, you're not just experiencing reality, you're participating in it. Whether that participation is an act of creation, selection, or both, the result is the same. Reality is not a static stage where you are a powerless spectator. You are part of the mechanism that brings the universe into focus. This is why some modern mystics and spiritually inclined scientists see no contradiction between physics and philosophy. They're two ways of exploring the same truth, that reality is deeply entangled with the act of being aware of it. Closing tease, and so we are left with a choice, or perhaps an infinite branching of choices. Is reality solid and mindless, with consciousness just a curious byproduct of matter? Or is reality fluid, pliable, and deeply intertwined with the very fact that we are here to witness it? If the latter is true, then the multiverse isn't just out there. It's something you are helping to navigate every moment you exist. In our next chapter, we'll explore what happens when this idea is taken to its furthest extreme. If infinite yous are living infinite lives, is there a version of you that has already discovered the ultimate truth? And if so, can you learn from them?